Hello. So we'll talk about one of the most important, mechanism for interprocess communication called as pipe. So pipe is used in operating system to allow data transfer between processes. It enables one process to send the data to the another in a unidirectional manner. Now, actually, when it does it as an unidirectional manner, ultimately it works as a data stream. And pipes, one can see that they are commonly used in Unix and Linux operating systems. For example, on Linux shell like this, suppose if I write ls-l and if I write grep, pipe grep, then I am writing here, say, double quote dot c. Okay. So in this, like when I apply this, it will display me all the things which are having or mapping that part. Now you must have seen here, like the output of ls-l is passed as an input to grep, what we wrote as a command like dot c, when using the pipe symbol. Now today we'll mainly talk about through a program, something called as unnamed pipe. Unnamed pipe, also called an anonymous pipe, which is a temporary pipe used for communication between related processes, such as parent and its child process. Say, for example, here ls-l is giving output to grep.c. Correct? The output of ls-l is given to grep command and it works with. So now, like if we have to really address the characteristics, one important characteristic of unnamed pipes or anonymous pipe is unidirectional. Here, the data flows only in one direction, from one end to another end. And it is limited to parent-child processes, where only processes that share a common ancestor can use the unnamed pipe. Okay. Further, like if we see, they can work, the pipe exists only in memory and disappears when the process terminates. And we are going to make use of a system called here in the program, something called as pipe. Okay, this would be used to create a pipe. Now the pipe is created using this pipe system call, which returns two file descriptors. Okay, now these file descriptors are meant for, one is for reading purpose and the other one is for writing purpose. Fine. So like pipe two, like as I stated, pipe would be creating a pipe in a unidirectional manner, correct? And that can be used in inter-process communication. Fine. So we'll try to see that through one of the program here. Fine. So let us write. So I'm creating. So like as I stated, as an habit perspective, we'll try to include stdio.h. Then we will include unistd.h hash include stdlib.h. Now what we'll do is we'll create file descriptors as an array. Okay, as I stated that it returns two file descriptors. One is for read and other one for write. So we will create an array of file descriptors. So I will declare this as one array of integer type. Now this will hold, correct. So this will hold, say we will write comment here, holds file descriptors for pipe, correct. Now, like we want to read and write into the file. So what we'll do is we will have one, say for example, variable where it will hold what exactly it is reading so that it can write into the other file. And that is the reason why we'll add one variable called as buffer. So let us say we are storing it with like size to be 100. Fine. So let us write the code. Now, while we create a pipe, okay, we have to create the pipe for that variable fd, okay, with where those file descriptors would be taken into consideration. So we'll fire a call to pipe with the parameter to be this fd, okay. If it is returning -1, that means pipe creation failed. So we'll display an error, p error, pipe creation failed. And then as usual, we'll go with exit code with status to be 1, so that to communicate that it's not working. Now suppose pipe is created. Now we have to associate the pipes, correct? Now what we'll do is, as I stated, from parent process, we'll write to the pipe, we'll write to the file, and from child process, we'll read from the file. And in child, we'll try to print what is to be, what we exactly we read, okay, from the file. Okay, so let us write if fork. Now we will create a parent child processes. So is equal to 0. That means we are talking about child process. This is meant for child process. Okay, this code will execute for child process. Now, like when it starts writing, sorry, reading from the file descriptor, okay, what are the value that is stored in the buffer? So we'll close first the file descriptor which was used for writing purpose. So we don't know which is starting and which is executing. So we'll go with. So we'll close the right end. This is for closing the right end. Fine. So we closed it. Now let us read fd of 0. Correct. File descriptor 0. What is to whatever we read, okay, would be stored in the variable buffer. Okay, because we want to read it. So we'll store it in the buffer. And what is the size of it? Size. So size would be like which would be adding here is like through the size of function. So we'll add size as the buffer. Correct. And then like as write system call requires only these 3 parameters. So we'll add semicolon over here. Fine. Now, once this is read in the buffer, we'll try to print it using printf. So let us print. So printf would be like child process received, sorry, child process received what? So whatever the value that it is reading in the buffer variable, correct? So here we will write buffer. Now exactly it is going to print the value that is available in the buffer. Fine. Now what we'll do is we'll close that file descriptor which was used by us for reading purpose. So fd0. Now while we read it, actually it is opened. So we are not too much worry about that part. Okay, now if there are errors, we'll try to resolve it, whatever the errors are. This code is meant for the child process. Fine. So here if is done. Fine. So now we will write the else part. What happens in the child process? Sorry, what happens in the parent process? So now, like the way that we closed file descriptor for write end, so we'll close for read end. Close FD0 with assumption that F0 is for read and 1 is for write. This is our assumption. We closed it. So you can say here closing the read end. Fine. Now closing the read end is done. Now we have to write to file descriptor 1. So FD1. Now we will write this string. Hello. Tomorrow is March 29. Fine. Now if we, because when we use write system call, we have to print the length. So let us compute the size, length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So we'll print 26 characters from here with assumption that we have counted correctly. Now, again, like once write is done to that FD1, so we'll close this, close FD1. Fine. Now we will wait for the child to finish. So that's why we have to write this wait. And the sales part is done. Now we will write return 0. So let us see, we will check our code whether it is working written correctly. So we have created a pipe here. This is for pipe creation. So if it returns -1, then it would be failing ultimately. Correct. Then if fork is equal to 0, close, else, close, then write, then close, then wait. Okay. Then this, then return, and then this. Let us save this and let us hope that it will get compiled. So GCC unnamed pipe example.c -m32. Okay, so we'll correct the spellings. And now we are done. Let us execute this. Now you must have seen it printed it, correct? But we could not see like whether the child and parent process were created. So we'll add something here with sleep. Sleep in child after printf. Sleep 10. Fine. And here we'll write /n and then we'll make here change as 27 characters. Fine. Okay. So let us save, compile. Now we'll add one more terminal and we'll try to see there the output. So here we'll write ps-aux grep a.out. Fine. We'll write this one. Let us execute this. Now it is waiting till the time one can see the processes are created. Now one of the processes reading it and one of the process writing. So once it is done, now you must have seen we haven't given any name to this pipe, and that is the reason why it is called as unnamed pipe. Fine. Now the meaning here, like for example, when we do talk about this code, what is the code that we saw? Fine. So if I say Emacs, Emacs and our code, say unnamed pipe example. Here, now when we see this FD0, like FD1 and FD0, because we are creating FD2, these are file descriptors used for pipe. FD0 is always read end of the pipe and FD1 is always write end of the pipe whenever we are creating. So when we create the pipe FD here, like for example, if you see this, pipe FD creates a unidirectional channel. Now, if pipe creation fails, then it displays pipe creation failed with error message and then exit one. Now, suppose it is successful, then it will call fork. Okay. And in child process, what we are doing is we are closing right end, reading in the buffer, what is the value that is available. Okay. And then we are printing that buffer value. And we are adding sleep only to see output on the other screen, like the way that I showed you a dot out. Like towards right side, you can see a dot out is occurring twice, like in the PS output. The child closes right end with FD1 since it only needs to read data. It then reads the value from the pipe FD0 and stores that data in the buffer. That's what it is doing here from because of read statement. And the message is printed like child received, child process received, and then percentage is replaced by what are the value that is passed from the parent process. And then child process closes the FD0, correct? This one. Now in parent process, what is happening? Parent closes the read end here. Then it writes a message to the pipe using write FD1. And the message is, hello, tomorrow is March 29. After writing this, parent closes that FD1, right end. And finally, it waits to ensure that the parent, like the waits for the child to finish before parent gets terminated. And that is the reason, like we wrote this wait. And this is how it works. So let us execute one more time. So we compile that code, say with this, then let us give call to this. And then you can try this here, a dot out, parent child processor created here, 7781 and 7782. Now, now as they finished, so a dot out are gone. And what exactly it did? It is reading from the pipe and writing to the pipe, writing via pipe. Right? And this is called as unnamed pipe.